Alright, so let's continue variational autoencoders after the intermezzo on joint and marginal probabilities. So remember, we have an input x, and that input x has a distribution p of x, and p of x we don't know. Alright? So what we're gonna do is we're gonna assume a prior here, and the prior is gonna be p of z. That's basically what I write here, p of z. And then we will have a posterior, and the posterior is the probability of x given z. Alright, so that's the situation. That's our encoder, and that's our decoder. So now we have two distributions here. Yeah, so what I want to do is have the joint probability of these two. So here in the intermezzo we have x and y, but x is gonna be p x given z, and y is gonna be p of z. Alright, so these are gonna be my two distributions. And the joint distribution is nothing more than the sum of these, the product of these, right? Because if I look at this one here, it's the same as probability x is 1 times the probability y is 1. Alright? So, this formula here is then p x given z times pz. And from this, I can calculate p of x given z as the joint of x and z divided by pz. Alright, so here, z given x, I can calculate using our good friend Bayes. That's p x given z pz divided by px. Now I could replace this with this, but it won't help a lot, because basically here you have your marginal, and remember, this is an integral of p x given z pz dz. Yeah. So that is my marginal probability. So I sum over z, and I have my two distributions here. Yeah, it's exactly what we do here and here. In the marginal. Now, this integral you can't compute, so it's intractable. Yeah? And so that means if you can't compute this one, you can't compute this one, nor this one. That gives me a problem. Yeah? So, the solution, of course, will be that we will make an assumption on the distribution of z. But, so here we cannot maximize likelihood of seeing training data. And the training data is our p of x. Yeah, but if we can't do it, we're gonna maximize a lower bound of p of x. Yeah? So we can't maximize the likelihood of seeing the training data. So we're going to try to maximize a lower bound of p of x.